Okay, based on your pre-assessments, we need to spend some time solving equations. We have practiced this a little bit through some warm-ups, but now we're officially going to review. We're going to start by making flow maps. Even though this is a review and I'm going to spend time reviewing, I'm not going to spend a whole lot of time reviewing this method. This is the only problem that I'm going to show that. But we can model these with our algebra tiles. Notice 3x, so I have 3 of these x tiles. And minus 2, we can't really show minus 2. We have to show that with negative tiles. That minus 2 we're showing with the 2 negative tiles. And it's equal to and balanced with on the other side. It says 10, so I've got 10 of those unit tiles. Now, the one thing that I want you to pay attention to is when we're solving these with algebra tiles, we focus on the fact that there's negatives. And in order to get rid of the negatives, we have to zero it out with positives. Remember when we did this last year? Now, I just turn those into 0 by adding in 2 yellows, 2 positives, but whatever I do to one side, I have to keep it balanced, so I'm going to be adding in 2 positives, 2 yellows to the other side as well. I don't need to worry about this part because this counts as zeros now. So what I can see is I have 3 x tiles that are equal to and balanced with these 12 tiles. And so the next step then is to start splitting this into groups. I've got 3 things here, so I'm going to split these into 3 separate groups. And that's when we can see that one of those x tiles is perfectly balanced with 4 of the unit tiles. That's the only review of the model that you're going to get. We're going to spend the rest of our time reviewing the flow maps. Same problem. We're going to look at it a little bit differently. And what I want you all to write at the top of your paper, I want you to write down the order of operations. Because when we are figuring out how these equations are built, we always need to pay attention to the order of operations because they're built using the order of operations. And the acronym that we use to remember what the order of operations is GEMMA. G for grouping symbols, E for exponents, M, which reminds us to do multiplication and division next, and A that reminds us addition and subtraction is how we finish up. So how does that relate to these equations? When I'm trying to build a flow map, trying to figure out what happened to x first, I'm following that order of operations. So when we take a look at this equation, 3x minus 2 equals 10, I'm focusing on the x. What happened to the x first? Do you see any grouping symbols in this equation? Anyone? No? Okay, so no grouping symbols. E for exponents. Do you see any exponents in this equation? No? No E for exponents. M for multiplication and division. Do you see any multiplication or division in this equation? Yes, and I'm glad that you said yes, because even though it says 3x, we know mathematicians are lazy, and that really means 3 times x. So yes, the x is being multiplied. It is being multiplied by 3. So was there multiplication or division? Yes, that's what happened first. The x was multiplied by 3. Continue on. We found multiplication, didn't see any division, so now we are to A for addition or subtraction. Any addition or subtraction here? Yes. And so after the x was multiplied by 3, then we see this subtract 2, so I know that's what happened next. And when I take x, multiply it by 3, and then subtract 2, I know that it's equal to and balanced with 10. So all of those things make it equal to 10. And then it's a matter of figuring out how to undo each of those things. I undo subtracting 2 by adding 2. Just like we saw with our model up here, the first thing I did is I zeroed out those negatives by adding in 2 positives. Just like this positive 2 is going to undo that negative 2. Or I guess the plus 2 will undo the minus 2. And I will undo multiplying by 3 by dividing by 3. Again, the whole reason I'm choosing to divide is because I know it's going to undo that multiplication. So after I do these things and then I undo those things, I'm going to be back to x. Another class tried to get away with just doing the flow map. We're not just doing flow maps. The flow map tells us how the equation was built so we know how to solve it, but then we still have to actually solve it. So 3x minus 2 equals 10. I'm just rewriting the problem here so that I can do these solving steps. First thing that I have to do is add 2. Why am I adding 2? So it will undo the subtract 2. So I'm going to put add 2. Now remember, this is a balanced scale, so anything I do to this side, I need to make sure I do to the other side of the equal sign. So here's the equal sign. I'm coming around to the other side of that equal sign, adding 2. Now remember, the whole reason I chose to add 2 was specifically to undo the subtract 2. So this is undone. I can go ahead and draw the line through it because those zero out. And I can focus on what's left. What is left that's not crossed out? 3x. And I know technically my part where I crossed it out, the subtraction isn't crossed out, but is the subtraction gone? Yeah, because I undid that subtraction with this addition. What is it equal to and balanced with? I don't take the 10, I don't take the 2, I do what it says, 10 plus 2. And 10 plus 2 is 12. Just like we saw when I added these 2 tiles and then balanced it, adding the 2 tiles over here. We now have 3x tiles balanced with 12 unit tiles. The next step to solve, we have now added 2 to each side and simplified it. Now we're going to divide 3. So again, watch how I'm showing that division. I'm drawing this line, not to say, hey, here's a new, the end of the problem. That line is a division line. And I am dividing by 3, and whatever I do to one side, we do it to the other side. Again, why am I choosing to divide by 3? Because it will undo the multiplication. So I can go ahead and draw that line through there saying those are now undone. Times 3 and then divide by 3, it divides out. And what is it that I'm left with? What is not crossed out? The x. What is it equal to? Not the 12, not the 3, but the 12 divided by 3, go ahead Emily, is 4. And now this is why I love the flow maps. The flow maps are also great for checking our answer. Because we're saying, hey, x is 4. And if x is 4, what happens when you take 4 and then you follow the flow map and you multiply by 3? What's 4 times 3? Marley, 12. Okay, and then we're going to take that 12 and we're going to follow that flow map. 12 minus 2, what do you get? 10. Is that what we were supposed to get? Yeah, so it checks out. So using the flow map to continue to check your answer is a great, it's one of the reasons why I love that flow map so much. Another way that you can check your answer, and this is what I thought was really funny from that pre-assessment, the last set of questions asked, is x equals 2 a solution? And you guys tried solving, which is fine, but it's not super efficient. Let's pretend like the problem says, is x equals 4 a solution to this equation? 3x, only what does 3x really mean? 3 times x. What are we checking? If x is 4. So 3 times 4 minus 2, is it equal to 10? I'm asking that question. And then we start simplifying using the order of operations. Grouping symbols are here really only to show that I'm substituting in. No exponents. Multiplication, yes, the multiplication, 3 times 4 is 12. And 12 minus 2, is 12 minus 2 equal to 10? Yes, so it checks out. That's all that you had to do on that last set of problems, and I know that that's not what you guys did do. Ended up being a lot easier than you thought. Okay, there's your review. Who feels comfortable enough that they can work on the next 2 problems with their groups without needing any extra help? Good, raise your hand if you still need some extra help. All right, go ahead and work with your groups. We'll come back together in a little bit. I'm pausing the recording so that students can work in their groups. Okay, coming back together on these ones, we can see that x is where we're starting, and just like before, I'm going to ask those same questions about the order of operations. So I'm probably going to write GEMA near every problem so I can remember to go through this process. Are there any G for grouping symbols? I don't see any parentheses or anything, so no grouping symbols. Any E for exponents? No exponents, no powers, so I don't need to worry about that. M is for multiplication and division. I'm going to now look in this equation for multiplication and division, and I can see that there is multiplication right here. If the letter, the variable is next to the number, that means that multiplication is happening, and this is going to become important on the next one. So x is indeed being multiplied by 2. That is the first thing that happened, is that multiplication. I know it happened first because the order of operations says multiplication would happen before anything else. And then I can now continue on. A is for addition and subtraction, looking in this equation. And yes, I see this addition here, plus 4. So the next thing that's happening is we are adding 4. All of these things happen to x and make it equal to 10. That's what the equation says. All of that stuff happens and it's equal to 10. So our job now is to figure out how to undo these things. I undo adding 4 by subtracting 4. And I'm going to undo multiplying by 2 by dividing by 2. This is how things were done to x. This is how things are undone to x. And when all those things are undone, I'm going to still have x. It's just now I'm going to know what the value of x is. So now it's time to show our work. I rewrite the problem. 2x plus 4 is equal to 10. And I follow these solving steps. The first thing I need to do is subtract 4. Why am I subtracting 4? Because it will undo adding 4. So where should I write subtracting 4? Right below the add 4. Because remember, the whole point of this is that it's going to undo it. And since it's being undone, that's how I know I can put that slash through it, because it's zeroing out. But before I do that, whatever I do to one side, I need to do to the other. So if I'm going to take away 4 from here, I need to take away 4 from the other side of that equal sign. Now that I've remembered to keep it balanced and do the same thing to both sides, now I realize, oh yeah, this is undone, so I can put a slash through it. So what is it that I'm left with? I added 4, but then I took away 4, so all I have is 2x. And that 2x is equal to and balanced with 10 minus 4 is 6. I don't write the 10, I don't write the minus 4, I write what 10 minus 4 is, which is 6. We have now subtracted 4 from each side, so the next thing that we need to do is divide each side by 2. Remember, this line means we're dividing. So I'm going to divide by 2, and to balance it, we're going to divide this side by 2 as well. Remember, the whole reason I chose to to divide was because I knew it would undo this multiplication. So again, I'm putting that slash through it to show that that is undone. And it leaves me with just x all by itself. X is equal to and balanced with 6 divided by 2 is 3. So x is equal to 3. And once again, you can check your answer. 3 times 2 is 6. And then following that flow map, 6 plus 4 is 10, just like it says it should be. Now remember this that I said up here, that when we see the number next to the variable, that's how I know that it's multiplication. So on this next one, as I'm trying to figure out what's happening to the new variable j, we're still going through this order of operations. Are there any grouping symbols here? Nope. Any exponents in the equation? Nope. Any multiplication or division? Yep. Where is that multiplication? Again, do you see a number right next to a variable? I had a lot of students tell me I started with j and then we subtracted 8. Understand what the relationship is. If it was j subtract 8, I would see a minus sign in between the j and the 8. And that's not what I'm seeing. We need to reinterpret what it is that we're seeing. And what we're seeing is j is multiplied by a negative 8. So it's not that we're subtracting 8, it's that we are multiplying by a negative 8. So was there multiplication? Yes. Then we move on to the A for addition and subtraction, looking in my equation. Any addition or subtraction? Yep. So that's what happened next. When I do these things to J, in that order, I end up with the result that it is going to be equal to 57. So now it's time to undo these things, and let's see how well you guys did on this. I undo subtracting 7 by adding 7. And I undo multiplying by a negative 8. How? How do I undo multiplying by a negative 8? Good. Caden. Yep, divide by a negative 8. So all we're focusing on is that we have multiplication. We're undoing multiplication with division. We multiplied by a negative 8, so I'm going to divide by a negative 8. Doing those things in that order, I will now know what J is equal to. Again, watch the solving steps. Watch how I show my work and make sure you're following Math Practice 6 and you're attending to precision. I do want you to show your work in this specific and precise way. First thing that I'm doing, I'm going to, I lost my cursor, add 7. Remember, I'm adding 7 because it will undo subtracting 7. So add 7 to one side and add 7 to the other side. The whole reason I chose to add was to undo this, so I know that that is going to be undone. That leaves me with a negative 8j, because this subtract 7 was undone with the add 7, and it's equal to and balanced with, actually add it together. 57 plus 7 is equal to 64. Now I undo this multiplication with division. Balancing it, whatever I do to one side, I'm going to do to the other side. And that leaves me with, remember, this is undone, so putting that slash through it to show that it's undone. I have J is equal to, and then we complete this, 64 divided by a negative 8 is equal to negative 8. Make sure you did not lose your negative, and let's go ahead and check our answer. Negative 8 multiplied by negative 8 is equal to a positive 64. And then I continue on through that flow map. 64 minus 7 is equal to 57, just like it should be, so it checks out. What questions do you have? Okay, then what I need you to do next, please compare these next two problems. So we're on our paper on the right-hand side now. Please compare these two problems with your groups. Go ahead and talk it through. Okay, talk to me. Similar, different, what's going on? What do you see? Miley. Yes, they're exactly the same except for grouping symbols. So are they going to be exactly the same? No. So we really want to make sure we're paying careful attention, and I'm so glad Miley called these grouping symbols. The name of this type of grouping symbol is a parenthesis, but she recognized that those parentheses were indeed a grouping symbol. So the first one you can fill out just fine. Let's not worry about solving it just now. Let's just build the flow map. What's happening to x first in this first problem? Any grouping symbols? No. Any exponents? No. Any multiplication or division? Yes. What is happening first, Allie? Yes, it's being multiplied by 6. Remember, when they're right next to each other, we're too lazy to even draw that dot for multiplication, so x is multiplied by 6. And next, Addie. Yep, then we subtract 12. When we do those things in that order, it's equal to negative 36. And now we can build our flow map in reverse order to undo these things. I undo subtracting 12 by adding 12, and I undo multiplying by 6 by dividing by 6, and I end up with x by itself. Now let's compare that to the one below it, where, as Miley already pointed out, we do have grouping symbols. So as I'm going through this order of operations and I ask, are there any grouping symbols? We say, yes. So those grouping symbols, those parentheses, tell us what happened first. What happened first, Jada? Yep. we subtract 12 first. Those grouping symbols tell us what happened first. So remember how A is for addition and subtraction, and that is at the end. So normally that would be the last thing that we do. We're skipping it. It's now the first thing we do because the grouping symbols tell us so. So after we take care of those grouping symbols, any exponents? No, still no exponents. Any multiplication? Yeah, there is multiplication. Just like, let's compare it to this one up here. See how the 6 and x are right next to each other? That means 6 times x. Do you see how the 6 is right next to the parentheses? Our grouping symbol, that means 6 is multiplied by the parentheses. So what happened next? We multiplied by 6. Do you see how that's different than up above? Did those grouping symbols change anything? Yeah. A lot more than maybe we initially realized. When I do those things in that order, it's equal to negative 36. So now it's time to undo. I'm going to undo multiplying by 6 by dividing by 6. And I'm going to undo subtracting 12 by adding 12, and I'm going to do it in that order. Let's quickly go through both of these problems now that we've built our flow maps, and we can see, yes, they're similar, but they are different. Let's see how much of a difference that makes. Solving step, 6x minus 12 is equal to a negative 36. What is the first thing I do to solve? Follow the flow map. We add 12. And whatever I do to one side, we do it to the other side. Remember? Undone. So I'm left with 6x, which is equal to and balanced with negative 36 plus 12. Use your calculators. Don't make silly mistakes. Negative 36 plus 12 is equal to negative 24. Next solving step, divide by 6. Whatever I do to one side, I do it to the other side. Remember, this is undone, and so I am left with just x, which is equal to and balanced with negative 24 divided by 6 is negative 4. Now the whole reason we make the flow map is so that when it's time to solve, we know exactly what we need to do. So this flow map is different. Follow the flow map, because this is the first time we're seeing this happen in this way and in this order. The first solving step that I need to take is divide by 6. And I know it might look different, it might look weird, but the whole reason I'm choosing to divide is because I know it's going to undo this. So remember, undone. Put a slash through it so that you know that it's undone. Which means what's left? X minus 12. Now, yes, you can keep it in parentheses, but remember the whole reason for those parentheses, the grouping symbol, is to say we did it first. It's the only thing that we have left. So we don't need to worry about those parentheses anymore. You can still put them there. They're just not necessary. And now we have on the right-hand side, negative 36 divided by 6, which is negative 6. I have now divided each side by 6. Now we move on. We're going to undo the subtraction by addition. So add 12. Remember, I'm adding 12 to undo the subtraction. Balance it, do the same thing to the other side. That part is undone, and it leaves me with x all by itself now, which is equal to, again, use your calculators, negative 6 plus 12 is equal to a positive 6. Did changing the order make a difference? Yeah, big difference, right? Negative 4 versus a positive 6. The homework that I want you to complete tonight is on the back side. It's the very last two problems. So this one right here that starts with negative 0.5x. Don't freak out. Just because they're decimals doesn't mean we freak out. It still means we build our flow map, and it still means we do and undo in the right order. That's it. Don't be worried about decimals. You guys can handle it. And this one. So make sure you pay attention to the order of operations. Know how it's built. Unbuild it, solve it, and finish those two for your homework. That's it for thanks for watching. We'll see you next time.